I welcome all of you on platform of YourPedia Education, and as you know, we are publishing the series of videos on the basis of our recent visit in first ever research and development fair, which was held in IIT Delhi, October 14 and 15, 2022. My today's interaction is with one of the very erudite and knowledgeable professor, Professor Rajaram Swaminathan of IIT Guwahati. Professor Swaminathan has done wonderful work in the field of biomedical, bioscience, bioengineering, and some of his very important discoveries are related to biophotonics, fluorometer, and all. So I had detailed discussion with Professor Swaminathan. Before we go and listen to the detailed interaction with Professor Swaminathan, I would like to share with you the project which was displayed in the fair. That is the name of that fair, as you know, is Invent I5 Global Innovation Showcase in IIT Delhi. And here the Professor Rajaram Swaminathan, my team could see and visit that particular project. The name of the project is PRATIDIPT, that is Hindi word, acronym for the work of professor, that is low cost, you can see low cost portable indigenous fluorometer for bioanalytical laboratories. It is very good because we want atmanirbharta in field of technology. We want self-reliant in we want to become self-reliant in that domain, and hence indigenization of the technologies is very good concept and very good idea. So this is all about the work of Professor Swaminathan, and it is his more than 20 years of hardship and effort which he's going to share with us. And let me also tell you, Professor Swaminathan is having diverse background of knowledge. I mean, he's started his career with the professor in chemistry, assistant professor in chemistry, then joined biotechnology department, and very sound knowledge of instrumentation electronics. And many of you already are aware that biotechnology department is a very broad domain, and you find students from electronics background, mechanical background, chemical background, biotechnology background, biomedical background, doing the interdisciplinary research in this field. So let's go and interact with Professor Swaminathan and know more about his domain of work and domain of research. Very good morning, Professor Rajaram Swaminathan, and welcome to YourPedia Education.
Yeah. Thank you so much for having me.
I must thank you, sir, for sparing your valuable time this morning for this interaction. Professor, you have done marvelous work in the field of biophotonics and fluorometer, and I'm very sure this entire interaction is going to be very, very helpful for all those students, researchers who are looking forward to pursue career in the field of bioengineering, biosciences, and all.
Right.
Professor, my entire interaction is related to the recent display of your wonderful project named PRATIDIPT, that is low cost portable indigenous fluorometer for bioanalytical laboratories, and it was displayed in the first ever R&D fair held in IIT Delhi, October 14th and October 15th. So I have collected some of the interaction point, Professor, and I'll be going ahead with those points, and I'll have interaction on the basis of those points with you.
Right.
So if you allow me, Professor, can I start with my first point?
Yes.
So my first point is related to beautiful campus of IIT Guwahati. So IIT Guwahati is one of the very good performer in the league of, I don't know whether we can call it in the league of old IITs or new IITs, but it is wonderful IIT, doing very good, sir. And also it is on the northern bank of river Brahmaputra, beautiful campus. We want you to tell us something about IIT Guwahati to us.
Yeah, IIT Guwahati is definitely a beautiful place. I think everyone should come here and experience the beauty. That will be the best thing. Actually, we are blessed with trees, lakes, mountains, and they kind of soothe our senses and probably even motivate us to be closer to nature. And nature, one learns a lot from nature. So I think it influences our work, our culture, beauty, and everything.
Okay. So Professor, IIT Guwahati is also ranked 7th in engineering institutes and 8th in overall category in our NIRF rankings, that is 2021. So I congratulate you and all the members of IIT Guwahati for that. IIT Guwahati is a great combination of smart people working in the natural beauty settings, we can call Gurukul kind of environment. So a little more from your side on that.
Yeah, actually, this is the collective effort of all our faculty, students, staff. Put together, they have all performed well, and that is the consequence of that. And also, we have great teams in this institute, great teams working together, and that kind of makes a difference, including probably collaborations abroad within India and all those things. So they are all adding up. But having said that, I must say that we still have to improve. We still have to go to higher peaks, scale higher peaks, and so on.
Okay, wonderful, campus, sir. Now I shift over to our discussion on your project, sir, and your field of research.
Right.
You come from the Department of Bioscience and Bioengineering.
Yeah.
Professor, first my introduction point will be related to these fields only. Normally, students are not much aware about the difference between bioengineering, biomedical, biotechnology, bioscience. So these terms are known, but people are not very clear about the difference.
Yes, yes. Actually, they are all, you can say, in a sense, applications of biology.
Okay.
Right. Bioengineering, for example, is applying engineering principles to investigate biological systems. Like you create nowadays a lot of attention on synthetic biology. You can create synthetic organisms. You can make a genome and make it work and create that kind of thing. And also, you can develop materials and devices which can probably replace some of the defective components in your body. Like now, it must be familiar already. You have artificial walls, heart walls, artificial limbs and prostheses, and so on. So that is the field of bioengineering. Biotechnology is a very old term actually, and it is basically uh, using biology as a technological tool to improve the quality of our society, health of the society, and so on. And the rest of the others are in some way linked to these two actually.
Okay. So, Professor, I've seen projects being done in biotechnology field by doctors, engineers also. I know many of the prestigious institutes, like one in Chandigarh PGI Institute is there. And I know my friends are running the projects on a field of medical science also. So is biotechnology as a field, overlapping field for doctors, engineers, something like that, sir, for research?
See, biotechnology is a very vast area because it encompasses fields like agriculture to, uh, maybe even the other extreme, maybe the human body and so on. But medical is very confined to the health itself.
Okay.
So health is not the entire part of biotechnology. Health is
Understood.
maybe a small part of it.
Understood. So now, Professor, we don't see anything related to biology in typical engineering colleges normally. I mean, IITs are Indian Institute of Technologies, and we don't find much focus on biology. Normally, we don't see that. So, what do we understand from bioengineering, and what is the motivation behind establishment of such department like biomedical department or bioscience department in Indian Institute of Technologies?
Actually, this started maybe about 20 years ago. This bringing the engineering students into the fold. I think, like the engineering students which come into IIT from JE, they have very good background in mathematics, physics, and chemistry. And today you need these subjects to excel in biology, because biology is also becoming very quantitative.
Right, sir.
And it requires a lot of modeling and computer related coding and understanding things in a more quantitative way. So it would be better to have a student who has a good background in mathematics, physics, and chemistry. So in that sense, I think it was started, and it is very valid reason. And I think we are already seeing some encouraging results on that.
Okay, so Professor, as you just now mentioned that biotechnology is a very broad domain, and medical is just one application of that. No, I want to ask you, like, if some student wants to excel in this field, let's say wants to have a really good research career in this field, how important is the knowledge of biology? which he must not have studied during his 11th and 12th standard classes. How important is the knowledge of biology for engineering graduates to excel in this particular field?
No, I think it is very important. It is actually, I would say, mandatory.
Okay.
Because the reason for that is there are a lot of challenges today which are mostly in the area of biology.
Okay.
I mean, I imply even challenges in the engineering discipline.
Okay.
So if you know biology, it makes it that much simpler.
Mm-hmm.
And biology, I would think, is like a ocean, like our Indian Ocean.
Mm-hmm.
So it's better to get familiar with it at a younger age. So if you learn biology in your college days, then it becomes easier for you to understand. It becomes difficult if you do it later on. And there are different levels in which you can understand biology. You can, like you jump in the surface of the water, or you want to go deep down and investigate further. So same with biology also.
Okay.
So I think in that way, if you analyze, I think a little bit of biology will help everyone.
Is required. Wonderful. Yeah. So it is an interdisciplinary domain, and the knowledge of this will really be very helpful in the research.
Yes.
Professor, my next point is related to you and your academic background. I was going through your profile, Professor Rajaram, and I found that you've done your BSc in chemistry, and then you did your MSc in biotechnology. And I want to ask you, did you study biology in 11th and 12th standard, sir? And during your BSc, was that also part of your curriculum?
Yes, I did study biology in class 11 and 12.
Okay.
And I really enjoyed it also.
Okay.
Actually, my first love was chemistry.
Okay.
And so I chose to pursue my BSc in chemistry.
Okay.
And then in those days, like in the 70s and 80s, biology was undergoing a massive transformation. And a lot of molecular aspects were coming in, like molecular biology, DNA technology, recombinant technology, all those were coming in. So then it became a realm for the chemistry people to jump in. Okay. And if you have a background in chemistry, then a lot of things get simplified in biology, especially if you want to understand chemical reactions, like the food which you eat, how is it broken down to generate glucose. There is basically all chemistry and the enzymatic reaction. So in that sense, it is useful to know chemistry when you are studying biology.
So, Professor,
so that way it helps.
Yeah. Sorry.
Yeah, continue.
So Professor, I was going through your profile and I found you are working in very interdisciplinary domains now. So I was curious to know that whether at standard of 11th and 12th, you were also studying the mathematics, or biology was only your field of studies?
No, I studied maths and biology.
Both.
Both.
So that combination nowadays we don't see in the students.
No, it is available, but I don't know. Some students, they try to, restrict their attention, but that is not a good idea. Okay. Sometime or the other, you will have to learn biology.
Good, sir. Professor, I want to ask you, you initially joined in IIT Guwahati as a assistant professor in chemistry department.
Yeah.
And now you shifted over to a biotechnology department at IIT Guwahati. Any specific reason for that?
Actually, when I was looking for a job, that time there was no biology department in IIT Guwahati.
Okay.
And in fact, it was not so common in other IITs also. Except maybe Bombay, where I did my MSc Biotech, and Delhi. Other IITs did not have biology department.
Okay.
So anyway, my PhD was in chemistry related work, spectroscopy. So I thought, okay, I will fit in the chemistry department in IIT Guwahati, and I got selected also. So I work in the interface of chemistry and biology. So for me, both are same. And later on, they started the biotech department in 2002. And then it was a choice for me to just migrate there, and that's what I did. And then I had an opportunity to start a new department, to build a new department, and I think I enjoyed it. And so I took up that role and I went forward.
So, Professor, you joined IIT Guwahati at exactly the time when you just now mentioned that these departments were, coming, like biotechnology, where focus was coming, and that departments were being created. I want to ask you, sir, like new IITs were created after 2008. New IITs,
Yeah.
what we know now, not a lot of IITs, and many other reputed institutes in India, including IICs. So, what is the status of such departments in new IITs now? Let's say if we talk about IIT Mandi, IIT Jodhpur, IIT Ropar, and all these new IITs. So, what, in your opinion, is the status of these departments, biotechnology and biomedical departments?
Uh, I I'm not 100% sure. I'm not fully knowledgeable on this, but uh, I think many of these new institutes probably don't have a full-fledged departments in biology.
Okay.
At best, probably they are subsidiary to some of the existing departments with some faculty having specialization in biology, or they have maybe a section devoted to biology or something.
Okay.
But that is understandable because see, starting a full-fledged biotech department is also a big challenge because you need a lot of funding and the facilities you have to set up is also very large.
Yes,
So
sir.
maybe they would be thinking that let us first get going with the traditional areas.
Yes,
And maybe these interdisciplinary areas can germinate later on, like it did in the past for the older IIT.
But do you think, sir, these things will evolve with pass of time? Are they? I
Yes,
mean,
yes, I think these will definitely evolve. In fact, biology itself is undergoing a huge transformation.
yes.
There are, like I said, synthetic biology and also nowadays CRISPR-Cas and all those kind of things are transforming biology. So I think definitely they will interest will sprout. People will switch fields, and then probably these will come up in maybe in a small way, and then later on it may evolve.
Yes, sir. Professor, now I'm coming to your research area, research domain. I don't know whether I'm pronouncing it properly, protein charge transfer spectra, which we call PRO-CHAR-TS, if I'm pronouncing it properly. It is now established as an innovative experimental approach to observe structural transitions in protein. In very simple words, please share with us the journey leading to the discovery of protein charge transfer spectra.
Right, right. So this is called protein charge transfer spectra. See, this was actually, it started with a serendipitous discovery, which was made by my student almost 22 years ago, in 2001, 2021 years ago. So, see, normally when you when you actually measure spectroscopy like invisible spectroscopy or fluorescence, uh, most molecules which absorb light or emit fluorescence, they are all having uh, aromatic groups, right, which are rich in electrons and so on. So this was one instance where we found that amino acid like lysine, which is a component of your protein, is emitting blue fluorescence like light in high concentrations like 0.5 molar. This was completely amazing because I have done my PhD on proteins and I know the groups in proteins which absorb light. And this was totally not following the convention. This is completely out of the expectation. So I was very curious. And then we investigated this further and we published some papers on that, saying that without having without having aromatic groups, you could have light absorption and light emission. But that was completely new that time, and nobody believed us. And so we kind of beyond a point we thought, okay, it is better to leave it. And then later on, I got uh, enthusiastic, and I could get some collaborators to look at the theoretical issues in this. Theoretically, we can explain what is going on. And I collaborated with Professor Ravi Venkatramani in PIFR Bombay. That was around 2014. And then together, both of us discovered this protein charge transfer spectra. So what we proposed is there is a photo-induced electron transfer when you shine light on protein which has these charged amino acids. That is, amino acids with having positive or negative charge like lysine, glutamine, histidine, arginine, aspartate, and so on. And we showed that this property is more related to charged amino acids in proteins, and then it is sensitive to proximity between the charged amino acids. And this could be a new tool because most of the DNA and proteins, if you don't have aromatic group, they are not spectroscopically active, they are silent. So here we had a tool where the protein is fluorescent, or the protein is absorbing light without adding any external label or external dye, because attaching a dye to a protein is a cumbersome process, number one, and number two, it is also toxic. It could be toxic. Making those chemicals may be toxic, so it doesn't promote green chemistry and all those kind of things. So this is a more environmentally safe way of looking without adding any label, just looking at the protein and understanding the structure from the intrinsic absorption and fluorescence. So that's why we got interested, and now a lot of groups have now corroborated our data, and now we feel very happy that it is getting the attention which was not there earlier. And a lot, this field itself is now kind of becoming, in a big way, it is coming. But non-aromatic absorption and emission, especially in proteins and also in other chemical molecules. And so we are quite happy about this whole thing.
It's a wonderful journey, Professor, and I congratulate you for this wonderful discovery also. And this.
Thank you. Thank you.
So my next question also is related to your another wonderful device and discovery, and that is related to fluorometer. So, Professor, can you please tell us in very simple terms, what do we understand by fluorescence, and what is a fluorometer, if I'm pronouncing it properly, and what do we understand by biophotonics?
Right. Fluorescence is basically the molecules absorb light, right? Like you have green leaves absorb light. So if you absorb light in the visible region, then you will get color because you remove one of the components from the violet, blue, indigo, green, yellow, orange. So once a molecule absorbs light, it goes to a higher energy level, higher electronic scale. And then this excited molecule, as we call it, can come down by using that energy either by heat or by emitting a photon like fluorescence. So when it emits a photon, normally at a longer wavelength, then we call it fluorescence. Right? So this is what is fluorescence. So fluorescence is an interesting property because it's a very sensitive way of detecting a molecule. Because light can be easily detected using sensitive detectors. And so you can actually identify the presence of very trace amounts of molecules using fluorescence. So it's a very good analytical technique. And fluorometer is a device to measure the fluorescence from the molecule. So how to quantify the intensity of fluorescence. That is the purpose of the fluorometer. And when you say biophotonics, photonics is actually the technique of creating and measuring and also manipulating the photons. And when you say biophotonics, it's basically how you can couple biology and photonics. That is, looking at basically the optical phenomena coming from biological materials, or how biology is contributing to photons. In what way is it generating, or in what way that is useful for identifying the biological component.
Right. Wonderfully explained, sir. And Professor, when I was going through your profile, academic profile, I happened to see this one video, which is a very short duration video, approximately 1.5 minutes. And I saw in your video one of your inventions, and that is available on YouTube. And I want to play, with your permission, sir. I want to play that video right now.
Sure.
And, I'll request you, once this video is displayed, I will request you to please explain what is the phenomena there, because I found it very interesting. So may I?
Should I explain when the video is on, or should I explain after?
Yes, sir. Both. I think when the video is on, you can explain it. That will be wonderful. So along with the video, your explanation can come, not an issue. But if I found that sound problem is there, maybe after the video is closed, I'll request you again to give us brief about that. So can we go for that, sir?
Yes.
Okay. So let me share that video, Professor. Is it visible, sir, on your screen?
Yeah, it is visible.
Okay. So let me play this now, sir.
Yeah, so this is basically, you can see LED detector sample chamber. So this is a very compact instrument, and this is the adapter and the electronics for interfacing the detector, and this is the display, and now we are showing you the LED. So you can see that you can increase or decrease the intensity of the LED with that knob. Now we are opening the sample chamber, and now this is the filter which will reject the excitation light and allow only the fluorescence to pass through. Just turning it on. Now we are putting a blank sample which doesn't contain any fluorescent molecule inside. So here the fluorescence is very, very little because it doesn't contain any fluorescence. It's just a test for the background signal. So now we are adding a small low concentration of fluorescein, and you can see the value is around 128. So this is a modest fluorescence which it is showing. So now we increase the concentration and we see a value about 1000. So this is able to faithfully tell you the concentration of the fluorescence. And here you see the similarity between the absorption measurement and the fluorescence.
Okay. So, Professor, it was wonderful video and explanation also. Just
it said recording had stopped.
yeah. So, Professor, it was a wonderful explanation from your side along with the video. And
Right.
may I ask you, sir, now after this explanation of the small video, I wanted you to link it with our, project that is PRATIDIPT. So how can we link this small learning of this small video with the project which was displayed in R&D fair?
See, I'm a firm believer that we should make the devices which we use in our country, especially for related to science and engineering and technology.
Right, sir.
If you see today, many of the scientific labs, many of the components, many of the even the consumables are ordered from abroad. Right. And I think if you want to call ourselves as a country which is the forefront of science and technology, we should make the things which we need. And so fluorometer is something which is not made in India, to the best of my knowledge.
Okay.
And we need, and this is a very, very basic instrument for chemistry lab, analytical lab, even for biology, pathology labs.
Right, sir.
And if you import these equipments, they are very expensive. They can cost several tens of lakh, 20 lakh, like that, 20 lakh, 30 lakh, which is a very large amount. So we need to find ways to make these machines. So this is an attempt in that direction. So the fluorometer which we have shown you, it's a very basic instrument with just 3-4 components like a LED with an optical filter and then detector and a sample chamber. So this can be easily put together with some electronics interface, and you can use it to measure fluorescence from your sample.
Okay.
And this is not going to cost a lot. It could maybe cost you 20,000 rupees.
Okay.
And this can be made by any company who is interested. We have patented this product. And it can be sold to many colleges. It can be sold to analytical laboratories, pathology laboratories, where they need to measure fluorescence. Depending on the application, you can change the LED wavelength, the excitation wavelength, or the filter. So it is quite customizable, and it will be a boon for the students and the analytical labs in the country if we make this machine in India.
It's wonderful. And you also mentioned very relevant point here, Professor, that we need to add up something related to electronics or instrumentation part into such basic projects. In fact, my next point of discussion was related to that only. I found in your research work a lot of emphasis being put on electronics and instrumentation part in all your inventions. So coming from the background of chemistry, sir, and biotechnology background, how do you manage, so much inputs into instrumentation and electronics domains?
Actually, this is something which I have not had any formal training myself. But when I was a PhD student, I was involved in optics alignment and so on, and I had a fair idea about how instruments work, although I didn't have the deep knowledge about the electronics part. So
Okay.
I knew that things can be put together with these combination, and then you can take help from experts in electronics. So that's what we did in the case of PRATIDIPT also. I had a student from electronics background who was doing a master's in biotech department, which is
Okay.
a good thing.
Mm.
And then Professor Nimade from electronics, he was willing to help. And three of us struck a team actually, and so we could make this product with the help of Nimade and others. And so that's the thing. So I think if you don't know some part, then that best is to collaborate with the expert, and then you will also learn something new, and they
Yes.
will also learn something new about
Yes.
biology.
Mm.
So
So if
that's how
this
it
kind
goes.
of interdisciplinary research is the need of the hour, and I think you have that
Yes.
luxury being in premium institute like IIT Guwahati
Yes,
to
yes. IITs facilitate these kind of possibilities.
this are there. Wonderful, sir. I was also going through your profiles where I found that you are presently guiding 7 PhD students. So looks like it's a quite cumbersome activity, sir, to guide 7 PhD students simultaneously.
Actually, I every PhD student is special,
Yes.
and I think it's like God has sent them to us to train them and make them better people or something. So that's the way I look forward. But mostly, I treat my students in as independent way as possible. I want them to stand in their own legs. There's strictly no spoon feeding or anything. They have to come up with ideas. They have to be independent as far as possible, because that is going to help them in future. So if you pursue it like that, so you don't have to sit with everyone all the time explaining every single thing. Let them evolve. They'll make mistakes, but let them evolve and then learn from their mistakes. And then you will see that they are all having new ideas. They are all coming up with new suggestions, and it's something which both of us benefit.
Yes.
So it's like I want to bring out the best among the students,
Mm.
and that's the way I look at it. And then I think if that is the goal, I think eventually you will find they all find their way, and they even exceed your expectations sometimes.
Yes, yes, that's wonderful. Professor, my next point is of discussion is related to the research facilities in your lab, and I want to link this particular question with what are the latest research areas where a student can think of pursuing his career in research or academics. Now, many of my viewers on this channel are those students who are looking for opportunities in the research areas in higher education domains, and they want to know that if we want to pursue like if we are doing presently biotechnology engineering or MSc or something, which areas of research should we choose to have a wonderful research career, academic career, or career in industries later on. So can you, sir, mention some of the focus areas in your domain of research?
Right. So your first question was about
Research labs, facilities in your
ah,
lab. That was yeah.
yeah. So we have modest facilities. We have a UV visible spectrophotometer for measuring absorption spectrum, and we have a spectroplurometer for measuring the fluorescence emission spectrum. And for our most of other needs, we use central instrument facilities and so on. And coming to your question about the areas, the frontier areas, I think the best way the students can learn the areas would be to see the latest research which is happening in top journals like Nature, Science, PNAs, and so on. That gives you a flavor of things which are happening. And plus, I think today we are like in the post genomic era, right? So we have all the protein and DNA sequences, and we are trying to make sense out of it. So I think the students should focus on the basics first, get the basics correctly, and then they can see the application areas like CRISPR-Cas, which is used for genome editing, and then the the final frontier is, of course, the understanding the human brain. That is one area which is totally unexplored and very little is known today. I think so. Those are the frontier areas, and also I think with the relevance to India, I think we have to look at how we can find solutions to many of the diseases which kind of bother our population. And many of these diseases actually are not prevalent everywhere in the world, but maybe more prevalent in India. So they should maybe work on those diseases, and that can benefit the country also.
Okay.
And other than that, I think you should probably look at the journals. They will give you the most recent latest areas, and see how you can fit in there.
Wonderful. Professor, when we talk about some research domains or some domains of knowledge like biotechnology, there are tremendous opportunities in the field of research and academics and all. But I want to ask you, sir, do we find equally good opportunities in the field of industries also? Like a student who is doing his specialization in biotechnology, biomedical science and all, he is also curious to know that whether I can pursue career in industries also. So what is your take on that, sir?
Industries, there is a lot of scope outside India.
Okay.
There are very sophisticated labs which produce very specialized products, devices, and so on. So definitely there are opportunities abroad, plethora of opportunities. Within India, I think the situation is also changing, and there are more industries coming up. So I'm sure with the new startups and all those things coming, probably opportunities will open up here also.
Okay.
And I'm hopeful that it will come up in a big way.
Okay. Professor, now we have come to almost an end of this wonderful session. And my last interaction point is related to your prospective students. Professor, when such interactions are published, students listen to that, they get influenced by your research work and they want to work with people like you. I want to ask you, sir, when you take some student under your mentorship, maybe for masters or PhD and all, what do you see in those students? How they can groom themselves? Think of a student who is maybe in the second year of his graduation or something, and he wants to work in the domain of your research, and he wants to someday work under your guidance for masters or PhD. How he or she can, groom herself or himself so that one day he can come under your mentorship. What do you see in your prospective students?
See, the students which I the qualities I look for in the student is, first they should be good in the basics,
Okay.
like the basics of maths, physics, chemistry, biology. That is very important, and they should number one. Number two is they should be confident, and they should be willing to take up new challenges and also learn new topics in subjects, in reading and everything. So they should not, they should step out of the comfort zone. That is the important thing. Many times I find students are not interested even taking some elective courses which is slightly outside their area, like quantum chemistry or something. They should come forward and learn new things. That is how they are going to change. That is the transformation. And also they should be willing to put the hard work in the lab, and also wait for the new results, challenging, exciting events to happen.
Okay, wonderful, sir. I'm very sure those students who will be listening to this interaction will get tremendously benefited by this, sir. And I again thank you, Professor Swaminathan, for sparing your time for this wonderful interaction and answering all my this interaction points in a very simple, lucid language way and very simplified way. So I thank you for that, sir, and I wish you all the very best for your research activities in future.
Thank you so much, and I also wish you all the best.
Thank you, sir.